Good morning, our students, and welcome to this ARS class. Today, we want to continue our discussion on set and set theories. And this moment, we are paying attention particularly on a particular aspect of a set called power sets. So, the concern is what is power sets? By the word of definition, a power set is a collection of all possible subsets of a set, say A, denoted by P of what? Of A. As a way of giving further illustration to this definition, consider a set defined by a capital letter what? A, such that this set is not an empty set. It has elements or members which could be defined as 1, 2, 3, or any other members. So when a set A is given by this, not an empty set, and one is interested to see or to know or to talk about the collection of all possible subsets of this set A, the person is talking about what? A power set. And it is defined as what? P of what? A. So this P of A stands for the collection of all possible subsets of this set A with the following members. So our concern now this hour becomes, how do we determine the number of all possible subsets that can be formed from this set what? A. We determine it by this formula that P of A is given as 2 raised to power what? N. Where this N stands for the number of elements inside this set what? A. This N is given as N equals number of elements in this set what? A. That is to say that if A has 3 members, just as this one in the illustration, to determine the power set of A, we are going to say 2 raised to power 3. That is 2 times 2 times 2, which gives us what? 8. That is how to determine the number of subsets that we can form from a given set. If you have something like that, A is defined by 1 and 2. This time around, the value of N becomes what? 2. And once you come here, you are going to say 2 raised to power 2, which gives you what? 4. And you now come to know that the number of possible subsets that can be formed from a set A having 2 elements is 4. And of course, we should bear in mind that an empty set is a subset of every set. So we are going to give illustrations about these power sets. So permit me to clean this and give some illustrations. The only thing I would want us to bear in mind is that we are talking about power sets. And then we say that it is noted by P of what? A, and it is given as 2 raised to power N. Where this A stands for non-empty sets, this N talks about the number of elements that are contained in this set what? A. Where P of A stands for power set of A. For instance, the first illustration we have here is number 1. We have a set A, and that set A is defined by 1 and 2. And the question of interest is that we should determine the power set of A and enumerate them. First of all, we determine the possible number of subset A, and then we enumerate them. What we are going to do is this. We know that for us to determine the power set, that we are going to use this formula that says the power set of what? Of A is given as 2 raised to power what? N. And this time around, our N is talking about number of elements contained in what? In A. And the number of elements contained in A here is 1, 2. So our N assumes the value of what? 2, which becomes that this is equals 2 raised to power 2, which is equals to what? 4. So the number of possible subsets that one can have from a set A having 2 elements is 4. How do we enumerate them? We are going to begin to enumerate them with an empty set, which we earlier had said is a subset of every set. So we begin our enumeration. So for us to write a power set of A, our P of A is given as, first of all, we have an empty set, comma. Then we go and write all sets with 1 element. That is singleton sets. All sets that we have that will have 1 element in them. They are going to be subset of this set what? A. We begin by this. We open. Here I have what? 1. This is a set. I close. I open again. This is also a set what? 2. I have this. Coming from this set A, I now have a set that has 1 element. And that 1 element is contained in this set A. I also have another element or another set that contains 1 element. That element is 2, which is as well contained in what? In A. So these are possible subsets that can be formed from this set A having only 1 element inside them. When we are done writing out all the sets with 1 element, we go ahead to writing all possible subsets with 2 elements. Then we start with this. We open. So we have 1, comma what? 2. We close it. There is no other subset that is possible to be formulated from this set A that is going to have 2 elements, because we have exhausted all the possible elements in this set what? A. And we should bear in mind that in sets, when we write 1, comma 2 inside the set, and another write what? 2, comma what? 1, in set and set theories, they mean the same thing, because the position of the elements inside the set does not change the cardinality of the set and doesn't change the value of what? Of the set. So in sets, a set defined as 2, 1 is the same as a set defined as 2, 1. This is 1, 2, the same thing as 2, what? 1. Therefore, having written this, we are not going to write this. Then we clean. We clean this one. We cannot proceed further because the maximum number of elements we have in our mother set is what? Is 2. Or we have what in the original set is what? Is 2. And you cannot have a subset that is going to have more than elements than the set that is given to you. So we have looked at an empty set as a subset. We have looked at what? A set with only 1 element. And then we have now looked at set with 2 elements. So we have exhausted all possible subsets. Then we count to know how many they are. We have 1, 2, 3, 4. And of course, this is what we have here. So to determine the number of possible subsets we have in a set A, we make use of 2 raised to power n, where this n stands for the number of what? Elements in the set that is given to you. Like we had A here, it is 1, 2, 2 raised to power 2 to give us 4. Let us do another illustration to drive this idea home further. Let us talk about a set now. This time around, I have 2, 1, 2, 3. This is a set. The question still says that we should go ahead and determine the number of the possible subsets here and equally enumerate them. We begin by determining the number of subsets, making use of the formula we earlier had defined. This time around, our n is going to assume the value of what? 3, because the number of elements in this set A is now 3. 1, 2, 3. So it becomes now, this is equals 2 raised to power 3, which is equals 2 raised to power 3 means 2 times 2, 4 times 2, 8. So the number of possible sets in a set with 3 elements is 8. So how do we enumerate them? We are going to enumerate them by, first of all, beginning with an empty set. When we are done with empty set, we go over to all sets with 1 element, such that those elements inside the sets are equally contained in the set that is given to us. When we are done by that, we go over to all possible sets with 2 elements, and those elements inside the set must be contained in the set given to us. From there, we go over to all possible sets with 3 elements. So as a way of providing the answer, we begin by, we have that our P of what? Of A is equals, we have an empty set, which is the first one. We now go over to all sets with 1 element, just 1 element. So we begin, here is 1, comma, we come over here, we have 2, here is what is 3. These are all possible subsets we can have with only 1 element inside them. There is nothing you can have again. You can't talk about 4 because 4 is not contained here. You cannot talk about 0 because 0 is not contained here. You can't talk about any other number because such number is not contained here, except 1, 2, 3. So we now go over to all sets with 2 elements, just 2 elements inside them. So we come here, we have this. Here is what? 1, comma what? 2. We open again. Here is what? 1, comma what? 3. We open again. Here is what? 2, comma what? 3. There is no other thing you can have again here, talking about set with only 2 elements. Because we have taken 1 and 2, which is here. We have taken 1 and 3, which is here. We have taken 2 and 3, which is here. If you talk about 2 and 1, it is the same thing as 1 and 2. If you talk about 3 and 1, it is the same thing as 1 and 3. And if you talk about 3 and 2, it is the same thing as 2 and 3. Because we had earlier said that the position of the element inside the set does not change the value of what of the set, or change the cardinality of what of the set. So we now go over to a set with all possible subsets with 3 elements. So we now go over. We have this, which is 1, 2, and 3. There is nothing you can have then again. So what we do is to go ahead and count the number of what of our subsets. Here is 1, 2, 3, 4, 5, 6, 7, 8, which is of course what we have here. However, we are going to pay attention here, and of course it is the reason of this class this moment, that when the cardinality or the number of elements inside a set continues to grow larger, it becomes difficult for us now to easily determine and enumerate all the possible subset of what of a set. And when it grows to that extent, we are going to use another approach that will help us to determine the number of possible subsets and equally enumerate them if the case arises. So permit me to clean these illustrations. What if now what I have here becomes, I have 1, I have 2, and I have 4 here, and I have 4. And the question still says that I should go and determine all the possible subset that is going to be there. And then when I determine all the possible subset that is going to be there, perhaps I should go ahead and enumerate them. It becomes very tedious for us to do now. And see questions that they can ask under this. The question they can ask us under this is, number one question there says, number 1, it says determine all the possible subsets. Determine all possible subsets. Number 2, it says now determine the number of subsets with 3 elements. With 3 elements. And then number 3, they say find the probability of the subsets with 3 elements. We are going to pay attention on how we are going to go about this. First of all, we are going to provide the answer of number 1. As a way of solving this, we have our solution. What we are going to do first of all is to remember that our P of A is given as 2 raised to power n. And this time around, our n is the number of elements inside the set A, 1, 2, 3, 4. So we have that this thing becomes what? 2 raised to power what? 4. And 2 raised to power 4 means 2 times 2, 4, times 2, 8, times 2, 16. So this is given as what? As 16. Okay. So we are now going, that is now the first thing. We have answered the first question, which is number I, or number 1. We have answered number 1. Number 2 says that we should determine the number of subsets with 3 elements. To determine the number of subsets with 3 elements, we are going to use a formula of what? Of a combination. That formula of combination we are going to use is this. We are going to talk about number 2. We talk about n combination what? R. N combination R. Of course, n here stands for what we are talking about, the number of elements here. But R here now is talking about the number of what? Elements in the subset I'm going to form. They say determine the number of subsets with 3 elements. So this time around, my n is talking about the number of elements in the set given to me ab initio. But this R is talking about the number of elements that will be contained in the subset that I'm going to form. And this time around, it is only 3 elements that is required. So this is going to be, I have what? 4 combination what? 3. And of course, you know that 4 combination 3 is given as what? 4 factorial all over. Here is 3 factorial all over 4 minus 3 factorial. And of course, you know that 4 minus 1 minus 3 is what? Is 1. So what I have becomes what? 4 factorial all over 3 factorial. Because 4 minus 3 is 1 and 1 factorial is 1. So what I have becomes this. To express this, what I have becomes what? 4 times 3 factorial all over 3 what? Factorial. This 3 factorial will cancel this 3 factorial. What I have is what? Is 4. So the number of possible subsets that can be formulated from this set A that will be able to have inside them only 3 elements. They are 4 in number. And then the question went ahead and says that I should find a probability of the subset with 3 elements. Do me a favor to clean this side now. What you are going to do is this. Of course, the probability is going to be the number of subsets with 3 elements all over total not possible subset that can be formed from that set. And we have given ourselves a formula which means the probability of subset with 3 elements. Permit me to write 3 S dot 3 to stands for subset with 3 elements. This is given as we have 4 combination what? 3 all over 2 raised to power what? 2 raised to power 4. How do we mean by this? To determine all possible subsets, we use 2 raised to power n. And here, the number of elements in this A is 4, so n becomes what? 4. This is what we have here. To determine the number of subsets with 3 elements inside them, we make use of what? Of our n combination R, where n still stands for number of elements in this set and R stands for the number of elements inside the set I will formulate, which is now 4 combination 3, and this earlier gave us what? 4 all, because this gave us 4 earlier and this one gave us 16. So this thing becomes 1 over 4. So the probability is 1 over 4. So that is how to go about to determine the number of a subset that is having a particular elements inside them when we are given a bigger set. Permit me to equally do another illustration quickly. So permit me to clean this. What if we are given a set like this? It might be any other set, not necessarily A. We are just using A for illustration. What if we are given a set like this? We have a set B, and this set B is given as what? We have what? A, we have B, we have D, we have E, we have what? H, and perhaps we have what? I. 1, 2, 3, 4, 5, 6. And then maybe we have N. Or let me use M. We have M. And the question here is that we should determine all possible subsets that can be formed from this set what? B. That is the first question. So we now say, for us to solve that, which is number 1, we are going to use a formula that says that this is 2 raised to power n, which of course becomes 2. Let us go and determine the value of n. Value of n is talking about number of elements inside that set. 1, 2, 3, 4, 5, 6, 7. So it is now becomes 2 raised to power 7. And of course, our 2 raised to power 7 is going to be 2 times 2 times 2 times 2 times 2